this video we're going to go over a radiation example. So just a bit of introduction about radiation. We have a black body and a grey body. A black body absorbs all the thermal radiation that falls onto it, and it also emits the maximum amount of thermal radiation. For a grey body, it reflects and transmits some of the thermal radiation, and it doesn't emit the maximum amount of thermal radiation. This symbol here is the black body emissive power, and it's the maximum radiation emitted from the black body. Because grey bodies do not emit the maximum amount of radiation, as per the definition up here, the emissivity of the surface, denoted by this symbol, is taken into account here. So we have the equation for the black body emissive power, and we have a variable here to take into account the emissivity of the grey body. And this symbol here is the Stefan-Boltzmann constant. So if we assume that one of the surfaces within the two bodies exchanging heat, if we assume one of them is a black body, then we only look at heat transfer by radiation. So we can use this equation here. So if we do an example, a piece of bread with sides 0.5 and 1.2. So 0.5 and 1.2 is placed on an oven maintained at 300 degrees Celsius. The initial temperature of the bread is 5 degrees Celsius. The surface of the bread has an emissivity of 0.9. Calculate the initial rate of heat transfer to the bread. So if we use this equation, because we assume the oven is a black body, so Q equals 5.67 times 10 to the negative 8, which is the Stefan-Boltzmann constant, multiplied by the area, so 1.2 multiplied by 0.5, which is 0.6, and then multiplied by the emissivity, which we're given as 0.9. Now for the temperatures, these are in units Kelvin, so we have to convert from our Celsius. So T1 is 300 plus 273.15 to convert to Kelvin. So 573.15 to the power of 4 minus 5 plus 273.15 is 278.15, and they're both to the power of 4. If we do this calculation, we should be able to calculate the heat transferred. Get 3120.81, and that will be joules per second, so watts. And that's it.